In this video, we'll be looking at the TVM Solver in the graphing calculator. To get to the TVM Solver, we'll hit the Apps button on the calculator. We'll then select Finance, and then TVM Solver. TVM stands for the time value of money and will be used for most problems that deal with compound interest. On the calculator, here we can see that there are a number of inputs. And at the bottom of the screen, we'll see the example that we'll use to explain how to use it. So if Chris has $1,000 in an account earning 2.1% annual interest, compounded monthly, and deposits $100 at the beginning of each month, how much will the account contain after 2 years? So the first input we'll put in is N. It's the total number of compounding periods or the total number of payments, which will be the same for all of our problems. So in this problem, Chris is making monthly deposits for 2 years. So what we'll do is we'll say he's making monthly payments, so that's 12 per year, times 2 years. So the total number of payments that Chris will make is 24. That's also going to be the number of compounding periods because his interest is compounded monthly for 2 years, so that's 24 as well. The next input is I%, and that's our interest rate. The percent indicates that we need to put in our interest rate as a percentage rather than as decimal. So Chris is earning 2.1% interest, so we'll just put in 2.1. PV is the present value, that is the starting amount, and so Chris is starting off with $1,000. Now, in the graphing calculator, money has to be directional. So anytime money is moving away from us, it's going to be negative, and anytime money is coming back to us, it's going to be positive. So a $1,000 investment would indicate the money is moving away. So that's negative $1,000. The payment that Chris is making is $100 at the beginning of each month. So our payment is also an investment, so it will also be negative. So payments and present values are very similar in that they can both be investments. A present value is going to be a one-time deposit, whereas a payment needs to be something that occurs regularly. FV is future value. That's going to be the ending amount. In this problem, that's what we're going to be solving for since we're asked to find out how much is in the account after 2 years. Now, we won't always be solving for future value. Any of those that we already filled out, we could be solving for. So in many of the problems, you'll be given some of the inputs and you'll solve for whatever's left. In this problem, future value is what's left for us to solve for. P/Y and C/Y, that's payments per year and compounding periods per year, and those will both be the same for this class. So the payments per year, he's making monthly payments, so that will be 12, and also his account earns 2.1% annual interest compounded monthly, so that's 12 as well. If his payments were quarterly, that would be 4. If they were semi-annual, that would be twice per year. If it was weekly, that would be 52 times per year, and so forth and so on. At the bottom, we see payment in begin. Now, if we look back at the problem, we see that Chris is making the deposits at the beginning of each month, so we need to select begin. Now, it won't always say whether the payments will be made at the beginning or end of the period. Sometimes it will say what type of annuity it is. Annuity is just a type of savings account. So an ordinary annuity, payments are made at the end of a period. An annuity due, payments are made at the beginning of a period. If it doesn't specify at all, we'll always assume end. Now that we have all of that in, we can solve for our future value. So we'll move our cursor up to future value, and we'll hit alpha and enter. So if we were solving for anything else, we would just go to that and hit alpha enter on it. So we can see that our future value is a positive number because we made a $1,000 investment and then another $100 investment every month. So that at the end of the time period, Chris could get that money back. And so that's $3,496 and about 7 cents that he could get back at the end of the time period. So the TVM solver can be used for most any problem that deals with compound interest. It can't be used for simple interest problems. It also can't be used for continuously compounded interest problems. And the reason why is because our payments per year and compounds per year can't be set at infinity, which would be a continuously compounded interest problem. They also can't be set at 0, which would be a simple interest problem. So for those two types of problems, we'll need the formulas. For anything else, we can use the TVM solver.